So welcome. This is a worksheet based upon the functions, but the subtopic is inverse functions and composition of functions, composite functions. So now coming to the first question, he's asking f of x is 10 minus 2x and g of x is 5x. What is f circle g of x? So f of g of x. So what does it becomes? F of g of x. G of x is 5x. Now plug in 10 minus 2 times of 5x. So what does that becomes? 10 minus 10x is going to be the answer. Whereas he is asking g circle f of x. So which is g of f of x. So g of f of x. F of x is 10 minus 2x. Plug in the 10 minus 2x. 5 times of 10 minus 2x. So it becomes 50 minus 10x. Now f inverse of x. So how should I be finding f inverse of x? For part B, so 10 minus 2x equals to y. So 2x equals to 10 minus y. So x equals to 10 minus y upon 2. So what will be f inverse of x? 10 minus x upon 2. Part C, g inverse of 10. So first of all, g of x equals to 5x. So y equals to 5x. So x equals to y upon 5. So g inverse of x equals to x upon 5. Now g inverse of 10 is being asked, which is 10 upon 5, which is 2. That is g inverse of x. Next, f inverse circle g of x. So part D, f inverse circle g of x. So f inverse of g of x. What is g of x? G of x is 5x. F inverse of 5x. So plug in that one over here. So it becomes 10 minus 5x upon 2. Now then g circle f whole inverse x. G circle f whole inverse x. So first of all, what should I do? I take g circle f of x. How much is that one? Is 50 minus 10x. 50 minus 10x. So y equals to 50 minus 10x. 10x equals to 50 minus y. X equals to 50 minus y upon 10. So g circle f whole inverse will be equals to 50 minus x upon 10. Then finally part E, f circle f of x and g circle g of x. So f circle f of x. So f of x. So what is f of x? 10 minus 2x. F of 10 minus 2x. 10 minus 2 times of 10 minus 2x. So it becomes 10 minus 20 plus 4x. So it becomes 4x minus 20. G circle g of x. G of x. So g of 5x. Then 5 times of 5x, which is going to be 25x. That's question number 1. Coming to question number 2, find f inverse. So we can see that plus becomes minus. So minus becomes plus. Plus becomes minus. Times becomes division. Division becomes times. Cube becomes cube root. So for over here, first plus 100 becomes minus 100. Times 3 will become divided by 3. Find f of 1. What is f of 1? F of 1 is going to be 3. F inverse of 1. When do I get 1 in F table? 5. So F inverse, you should see the other way. F of x equals to 2. When do I get 2 in F table? 6. So x equals to 6. Then F inverse of x equals to 2. Same. What is this? F inverse of x equals to 2. So F inverse of x equals to 2. So x equals to f of 2. What is f of 2? 4. So x equals to 4. Question number 4. G of 3. G of 3 is 1. F inverse of 3. When do I get 3 in F inverse table? 4. Next, F circle G of 2. So f of G of 2. What is G of 2? 3. And f of 3? Negative 1. G circle G of 3. G of 3. What is G of 3? 1. What is G of 1? 5. Next, G circle f of x equals to 3. G circle f of x equals to 3. So, what is the value of x? He is asking us to find it out. So, G circle f of x equals to 3. So, how should I be able to do so? But for that, first of all, I should know what is G circle f. For that, if at all we don't know, what am I going to do? That one is just move this 3 over here and write it out over here. So, I am applying G inverse on both sides. So that G and G inverse gets cancels. F of x equals to G inverse of 3. When do I get 3 in G table? 2. F of x equals to 2. Next, apply F inverse on both sides. So F and F inverse gets cancelled. So x equals to F inverse of 2. When do I get 2 in F table? 1. So x equals to 1. Find the inverse. F of x equals to x upon x plus 5. So x upon x plus 5 equals to y. So x equals to xy plus 5y. X minus xy equals to 5y. X common 1 minus y equals to 5y. X equals to 5y upon 1 minus y. So it becomes 5x upon 1 minus x. That's going to be the answer. Question number 6. F of x equals to 2 power x, g of x. Find g circle f of x or g circle f of 3. So g of f of 3. Plug in f of 3. So it becomes g of 2 power 3. 2 power 3 is 8. Plug in 8. 8 upon 8 minus 2, which is 8 upon 6, which is going to be nothing but how much? 4 upon 3. G inverse 5. So part B is asking G inverse of 5. So first of all find G of x. G of x equals to x upon x minus 2. So y equals to x upon x minus 2. So xy minus 2y equals to x. Xy minus x equals to 2y. Take x common, y minus 1 equals to 2y. X equals to 2y upon y minus 1. So G inverse of x equals to 2x upon x minus 1. So G inverse of 5 will become 10 by 4, which is going to be 2.5. Now, that's going to be the answer. Method B. He told, instead of finding G inverse, which is in method 1, you can do it out in another method. What is that another method? Definitions, G circle f of 3, and then find it out. So G circle f of 3 can also be written as G of f of 3. What is f of 3? F of 3 is nothing but what just now we got it as 8. Then plug in 8. 8 value is going to be nothing but how much? G of 8, but we don't know the function. What is the value of G of 8? So if at all I do G of 8, what am I going to get? 8 upon 8 minus 2, which is nothing but what? 4 upon 3. But what am I interested in? I am interested in nothing but what? G inverse of 5. I am going to get it out in the value of G inverse of 5. So how should I use that one? So see carefully. G inverse of 5. The question being asked is G inverse of 5 equals to how much? Let it be equals to x. So when I move G inverse to this side, 5 equals to G of x. So when do I get 5 it out in G table? So 5 equals to G of x. What is G of x? G of x is x upon x minus 2. So it becomes 5x minus 10 equals to x. So 4x equals to 10. So x equals to 10 upon 4. So x equals to 2.5. The same answer I'm going to get. So you can do it out in this method also, where g inverse of 5 equals to x. From there, you can get the value of x. Now, question number 7. The function f is given by f of x equals to x square. X lies between 0 to 3. Sketch the function. So, when it is 0, it is 0. When it is 3, it is 9. So, 0 to 9. Then, state the domain and range. Domain is x lies between 0 to 3. Range is y lies between 0 to 9. Now, write the inverse. Square root of x will be the inverse. On the same axis, draw this graph. It's going to be in this way. Again, it passes through 1, 1 and so on. Next, state the domain and range. So, domain and range will be getting swapped. So, the range becomes the domain and the domain will become the range. Question number 8. The graph of the function f is shown below. Find f of 0. F of 0, negative 2. F of 2 is 0. F of 4 is 2. Write down f inverse of 3. When do I get 3 in f table? It is at 5. When do I get 8 in f table? At 6. When do I get negative 1 in f table? 1. And when do I get 0? You can see from the graph, it is 2. Now f of x equals to 0. When it is equals to 0? At x equals to 2. F of x equals to 2. When it is equals to 2? When it is equals to 2? At 4. Now sketch the graph of f inverse. So what should I be doing for sketching the graph for f inverse? Write all the points. So what all the points are? First point was 0, negative 2. It becomes negative 2, 0. Next point was 2, 0. It will become 0, 2. Next point is 5, 3. It becomes 3, 5. And the next point is 6, 8. It becomes 8, 6. So negative 2, 0. Then 0, 2. 3, 5. And 8, 6. 8, 6. So join them. This is going to be the answer. Question number 9. F of x is given. Show that f inverse is f. So for finding f inverse, what should I be doing? Y equals to 2x minus 3 divided by 3x minus 2. So 3xy minus 2y equals to 2x minus 3. 3xy minus 2x equals to 3 plus 2y. Take x common. 3y minus 2 equals to 3 plus 2y. So x equals to 3 plus 2y upon 3y minus 2. So therefore f inverse of x equals to 3 plus 2x upon 3x minus 2. You can see that both are the same. But are we getting the same? So it was negative 3 over here. We are getting the same answer. So it was negative 3 plus 2y over there, and we get the same answer. Part B. F circle f of x equals to f of x, and it's a 4 marks question. F circle f of x. So it is f of x. What is f of x? F of x is 2x minus 3 upon 3x minus 2. Now plug in that one. What does it becomes? 2 times of 2x minus 3 divided by 3x minus 2 minus 3 divided by 3 times of 2x minus 3 upon 3x minus 2 minus 2. Now what does that becomes now? Both the denominators gets cancels. 2 times of 2x minus 3 minus 3 times of 3x minus 2 divided by 3 times of 2x minus 3 minus 2 times of 3x minus 2. So what does that becomes now? 4x minus 6 minus 9x plus 6 divided by 6x minus 9 minus 6x plus 4. It becomes negative 5x upon negative 5, which is going to be equal to x. That's going to be the answer. So coming to the next question. Question number 10. F of x equals to x cube. Find f inverse. F inverse will be cube root of x. Then g of x, f circle g of x equals to x plus 1. Find an expression for g of x if f circle g of x equals to x plus 1. So f circle g of x equals to x plus 1. So I should be finding it out. What is that function? So f of g of x equals to x plus 1. But what is the meaning of f of x? F of x means x cube. So g of x whole cube. G of x whole cube equals to x plus 1. So what is g of x will become? G of x equals to cube root of x plus 1. That's going to be the answer for g of x. Now go to g circle f of x. G circle f of x equals to x plus 1. So what does that becomes? G of f of x equals to x plus 1. But what is f of x? F of x equals to x cube. X cube, g of x cube should be equals to x plus 1. So what should be the value of g of x? So when I'm plugging it out x cube in the function g, then I'm going to get it out x plus 1. So obviously, what does it becomes? G of x will become cube root of x, because x cube's opposite is cube root of x, because x cube is becoming x, and what else getting added? 1 is getting added. So g of x is going to be cube root of x plus 1. So that when I plug in x cube, cube and cube root gets cancelled, I get x, and plus 1 is already there. So g of x is going to be cube root of x plus 1. Question number 11. F circle g equals to h. Express f in terms of h. So f circle g equals to h. So what am I going to do it on? I am applying g inverse on both sides. Circle g inverse, circle g inverse. Then g and g inverse gets cancelled. So f equals to h circle g inverse. B. F circle g equals to h. I want g in terms of h. So therefore apply f inverse on both sides. F inverse. So what does it becomes? F and F inverse gets cancelled. So g equals to F inverse circle h. Finally, what is he asking? F circle g circle h equals to k. Find g in terms of f, h and k. So apply h inverse on the right hand side and f inverse on the left hand side. So that f and f inverse, h and h inverse gets cancelled. So my final answer is g equals to f inverse circle k circle h inverse is going to be the answer. Question number 12. G of x equals to 3x minus 2, h of x equals to 5x upon x minus 4. Find h circle g of x. So it becomes h of g of x. H of g of x. What is g of x? 3x minus 2. Plug in 3x minus 2, 5 times of 3x minus 2 divided by 3x minus 2 minus 4. So it becomes 15x minus 10 divided by 3x minus 6. Solve the equation h circle g of x equals to 0. So this entire thing should be equals to 0. So 15x minus 10 upon 3x minus 6 equals to 0. So 15x minus 10 equals to 0. So x equals to 10 upon 15, which is equals to 2 upon 3. Question number 13. Find f circle g of x. F circle g of x. So it becomes f of g of x. F of g of x is x plus 2. Plug in that one 3 times of x plus 2. So which is going to be nothing but what? 3x plus 6. Next is asking f inverse 18, g inverse 18. So first find f inverse of x is x upon 3. G inverse of x, which is x minus 2. Now f inverse 18 plus g inverse 18. So which is 18 upon 3 plus 18 minus 2, which is 6 plus 16, which is equals to 22. That's going to be the answer. Coming to question number 14, find f inverse of x. So 2x plus 1 equals to y, 2x equals to y minus 1, x equals to y minus 1 by 2. So f inverse of x equals to x minus 1 upon 2. Next is asking g circle f of minus 2. So g of f of negative 2. So g of f of negative 2 is negative 4 plus 1, which is going to be negative 3. G of negative 3. 3 times of negative 3 whole square plus 4 or minus 4. So which is going to be 23. Then finally is asking find, I move this one over here and move this one over here. So coming to part C, f circle g of x. So it becomes f of g of x. What is g of x? G of x is nothing but what? 3x square minus 4. So f of 3x square minus 4. So 2 times of 3x square minus 4 plus 1. So it becomes 6x square minus 8 plus 1. It becomes 6x square minus 7. That's going to be the answer. Question number 15. F of x is given. Find f inverse of 5. So first, square root of f inverse of 5. So what am I going to do? F inverse of 5 equals to x. So 5 equals to f of x. So 5 equals to square root of 3 minus 2 times of 5. 2 of x. So squaring on both sides, 25 equals to 3 minus 2x. So 2x equals to 3 minus 25. So 2x equals to negative 22. So x equals to negative 11. Question number 16. G circle f of 3. So g of f of 3. So g of f of 3. F of 3 is nothing but what? Square root of 7. Now square root of 7 whole square. So it becomes 7. F inverse of x. So square root of x plus 4 equals to y. X plus 4 equals to y square. So x equals to y square minus 4. So f inverse of x equals to x square minus 4. What is the domain of f inverse? Domain of f inverse will be the range of f. So we can see that square root of always a number will be positive. So therefore the range of f is going to be y is greater than or equals to 0, which will be the domain of f inverse, which is x greater than or equals to 0. Question number 17. G circle f of minus 2. So g of f of negative 2. So g of f of negative 2. So negative 2 whole cube minus 4. So g of negative 8, negative 4. So g of negative 12. Plug in negative 12 2 times of negative 12. So which is negative 24. F inverse of x. x cube minus 4 equals to y. X cube equals to y plus 4. X equals to cube root of y plus 4. So f inverse of x will become cube root of x plus 4. Question number 18. F circle g of 4. So f of g of 4. G of 4 will become 1 upon 4 minus 3, which is f of 1. F of 1 will become 2 times of 1, which is 2. Now part B, g inverse of x. So 1 upon x minus 3 equals to y. So 1 equals to xy minus 3y. So xy equals to 1 plus 3y. X equals to 1 plus 3y upon y. So g inverse of x will become 1 plus 3x upon x. Write the domain of g inverse. So range of g inverse, this cannot be equals to 0. It can be never be equal to 0. You may get a positive number or a negative number. So the domain will be x is not equals to 0. So the range is, the range of g is, it can be never be a negative 0. So therefore that will be the domain of g inverse. Question number 19. F inverse of 2. F inverse of 2 equals to x. So 2 equals to f of x. So 2 equals to 3x plus 5. 3x equals to negative 3. X equals to negative 1. G of f of negative 4. G of f of negative 4. F of negative 4 is 3 times of negative 4 plus 5. So g of negative 12 plus 5, which is g of negative 7. Plug in negative 7 over there. So 2 times of 1 plus 7. So which is going to be nothing but how much? 16. That's going to be the answer. Question number 20. G circle f of x. G of f of x. So g of f of x is cos x. So it becomes 2 cos x plus 1. Then f of g of x. F of g of x is 2x plus 1. So it becomes cos of 2x plus 1. Next, g circle g of x. So what will happen is g and g inverse gets cancels. It's going to be x. G and g inverse gets cancels. It's going to be x. Question number 21. G inverse of x. So 6 minus x upon 2 equals to y. 6 minus x equals to 2y. So x equals to 6 minus 2y. So g inverse of x equals to 6 minus 2x. Next, f of g inverse of x equals to 4. So f of g inverse of x is 6 minus 2x equals to 4. So plug in that over there. 6 minus 2x minus 1 equals to 4. 4 cancels. What does it becomes? Next, so from there I should be able to get the value of x. So 6 minus 2x minus 1 equals to 1. So 5 minus 2x equals to 1. So 2x equals to 4. So x equals to 2. That's going to be the answer. Question number 22. G inverse of x. So 2x minus 3 equals to y. 2x equals to y plus 3. X equals to y plus 3 by 2. So G inverse of x equals to x plus 3 upon 2. F of g of 4. F of g of 4, it is 8 minus 3. So which is f of 5, which is 5 square, which is 25. Question number 23. G of f of x. F of x is nothing but what? 7 minus 2x. So 7 minus 2x plus 3. So which is going to be nothing but how much? 10 minus 2x. Then g inverse of x, directly x plus 3 becomes x minus 3. Next part, f of g inverse of 5. G inverse of 5 will become 5 minus 3, which is f of 2. Plug in f of 2, 7 minus 2 times 2, which is nothing but what? 7 minus 4, which is 3. Question number 24, h of x, which is f of g of x, 2x minus 5. So 3 times of 2x minus 5, which is going to be nothing but how much? 6x minus 15. H inverse of x. So y equals to 6x minus 15, 6x equals to y plus 15, x equals to y plus 15 upon 6. So h inverse of x equals to x plus 15 upon 6. F inverse of g of x. So f inverse of 2 power x. So f inverse of x, basically f inverse of x is nothing but what? X square. So it becomes 2 power x whole square, which is 2 power 2x. Next, f inverse circle g of x equals to 16. So 2 power 2x equals to 16. So 2 power 2x equals to 2 power 4, 2x equals to 4, x equals to 2. Consider the functions, solve these equations. F inverse of g of x, which is f inverse of g of x. G of x is x minus 2. F inverse, this one will become minus becomes plus and times will become 3. So f inverse of x is nothing but what? X plus 5 upon 3. So x minus 2 plus 5 upon 3, which becomes x plus 3 upon 3, should be equals to g inverse of f of x. So which is g inverse of f of x. F of x is 3x minus 5. What is g inverse? X minus 2 will become x plus 2. So 3x minus 5 plus 2, which is nothing but what? 3x minus 3. Then do the cross multiplication. X plus 3 should be equals to 9x minus 9. So 8x equals to 12. So 8x equals to 12. So from there, x equals to 12 upon 8, which is 3 upon 2. Question number 27. F of x is given, g of x is given, h is g circle f, find h of x. So g circle f of x. So g of f of x. What is f of x? F of x is 4 upon x plus 2. So plug in that one. 4 upon x plus 2 minus 1. This is going to be h of x. Now inverse of this one. So 4 upon x plus 2 minus 1 equals to y. 4 upon x plus 2 equals to y plus 1. 4 equals to xy plus x plus 2y plus 2. So x common, y plus 1 equals to 4 minus 2y minus 2. So what does that becomes? X equals to 4 minus 2y minus 2 upon y plus 1. So what is h inverse of x? 4 minus 2x minus 2 upon x plus 1. Now f of x is given, g of x is given, f circle g whole inverse. So first f of g of x. G of x is x cube. So it becomes x cube plus 1. So its inverse will be, if at all we want to find the inverse, how should I be finding it out? X cube plus 1 equals to y. So x cube equals to y minus 1. X equals to cube root of y minus 1. So f circle G whole inverse will be equals to cube root of x minus 1. G of x is f of x. So what is g of x? So f of x. F of x upon x plus 1. So plug in that one. So x upon x plus 1 divided by x upon x plus 1 plus 1. What does that becomes? X upon x plus 1 divided by x plus 1 upon x plus 1. X plus 1 gets cancels. X upon 2x plus 1. G circle G of 2. So G of 2. So G of 2. What is G of 2? 2 upon 5. Plug in 2 upon 5. 2 upon 5 divided by 2 times of 2 upon 5 plus 1, which is going to be 2 upon 9. Coming to question number 30, find f inverse of x. So 3x minus 4 upon x plus 2 equals to y. 3x minus 4 equals to xy plus 2y. 3x minus xy equals to 4 plus 2y. X common, 3 minus y equals to 4 plus 2y. So x equals to 4 plus 2y divided by 3 minus y. So what will be f inverse of x? 4 plus 2x divided by 3 minus x. Now what's going to be the domain? So domain means I should not substitute x equals to 3, so that the denominator will become 0. So except 3, I can substitute any value in this f inverse function. So x is not equals to 3. Question number 31. Show that f of x can also be written like this. So this is completing the square. X square minus 6x plus 9 subtract 9. So it becomes x minus 3 whole square plus 4. Hence find f inverse of x. So x minus 3 whole square plus 4 equals to y. So remember, for quadratic, whenever we want to find the inverse, we are doing it out, completing the square, then finding the inverse. So x equals to 3 plus minus square root of y minus 4. But x is greater than 3. So therefore, inverse will be always positive. So f inverse of x will be 3 plus square root of x minus 4. Now, hence find the domain and range of this one. So domain and range for f. What was the domain of f? Domain of f was x is greater than or equals to 3 and range is greater than or equals to 4, because it is 4 plus something will be greater than or equal to 4. So for f inverse, it will swap. X is greater than or equal to 4 and y is greater than or equals to 3. This is for f inverse. They get swapped. Now question number 32. Find f of 1. f of 1. f of 1 is 3. f of 3 is 2. G inverse of f of 4. So G inverse of f of 4. f of 4 is 1. When do I get 1 in G table? 3. So answer is 3. Find the solution of f circle G of x equals to 1. F circle G of x equal to 1. When do I get 1 in F table? When do I get 1 in F table? 4. So G of x equals to 4. When do I get 4 in G table? 1. So x should be equals to 1. Then finally G circle G inverse of 2. G and G gets cancelled. So answer is 2 for part D. Part A, part B and part C and D. Question number 33. The graph of the function is shown below. On the same diagram, sketch the graph of f inverse of x. So f inverse of x will have, this is minus 2 comma 1. So it will become 1 comma minus 2. And this is 6 comma 9. It becomes 9 comma 6. So this is 3 comma 2. It becomes 2 comma 3. So that should be the shape. Question number 34. The functions f of x and g of x are given. The function f circle g of x is defined by this one. Find the values of a and b. So f of g of x. What is g of x? G of x is x square plus x. Now what does that becomes? Square root of x square plus x minus 2. Now what is this? Is defined for x equals to r. Then we know that x square plus x minus 2 should be greater than or equals to 0. So when I draw the graph, it will be approximately in this shape. This is negative 2 and 1. So a equals to negative 2 and b equals to 1. Then range of f circle g of x. So we know that it is always, what is this? Greater than or equals to 0. For this all, it is always positive. So therefore, y greater than or equal to 0 is going to be the range. Because the reason is this square root of this one is not possible for negative numbers. So therefore, I took a as negative 2 and b as positive 1. So it should be always positive for less than negative 2 values and greater than 1 value. So therefore, the range is always positive, which is y is greater than or equal to 0. Question number 35. F of x is given, g of x is given. Given that g inverse and f inverse exists, what is the smallest value of a? So we have to do by completing the square. Whenever we do the completing the square, the vertex is going to be the smallest value of what is that function. So how do I find it out? The vertex x value is going to be minus b upon 2a. So minus b upon 2a is going to be the vertex. So x coordinate of the vertex is going to be the, what is this, minimum, what is this value of a. So how do I find that one? Minus of minus 12 divided by 2 times of 3. So what is that? Equals to 2. Then largest possible value of b. Again, largest possible value of b is going to be the same thing. Minus of minus 12 divided by 2 times of 3, which is going to be 2. Write down the within the domains determined in A, find f inverse of 7. So what am I going to do? F inverse of 7 equals to x. So f of x equals to 7. Use a GDC and check when do I get it out 7 in that one. So 4. Draw the graph on the GDC and check when do I get it out 7 on the graph. Then g inverse of 7 equals, what is the value of g inverse of 7? So g inverse of 7 equals to x. So 7 equals to g of x. Draw the graph of g of x on the graphing calculator and check when do you get it out 7. So answer is going to be nothing but what? 0. Coming to question number 36. So it has been given f circle g of x equals to 2x plus 1. So f of g of x equals to 2x plus 1. So g of x equals to nothing but what? F inverse of 2x plus 1. So I should find f inverse, then I should be doing it out f inverse of 2x plus 1. So for that, x cube minus 1 equals to y. So x cube equals to y plus 1. So x equals to cube root of y plus 1. So f inverse of x equals to cube root of x plus 1. So f inverse of this one will become cube root of 2x plus 1 plus 1, which becomes cube root of 2x plus 2, that is g of x. So for part B, g of f of x equals to 2x plus 1. So g of f of x is x cube minus 1 equals to 2x plus 1. So what is that? I'm assuming it out. Let y equals to x cube minus 1. So x cube equals to y plus 1. So x equals to cube root of y plus 1. So x is nothing but what? Cube root of y plus 1. So what is happening over here? If this is y, it is becoming, what is this? So we can write it out from here. So x is nothing but what? Cube root of y plus 1. So it becomes 2 cube root of x plus 1 plus 1. That's going to be the answer. So in that way, what I can do it out is the g of x. This is a shortcut method, so somewhat confusing to understand. So pause the video and check that carefully. So what is that is, I am assuming y as x cube minus 1. So then what was x will become? X will become square root of cube root of y plus 1. So I can write it out over here. In that case, my question will become g of y will become 2 cube root of y plus 1 plus 1, means g of x equals to 2 cube root of x plus 1 plus 1. Now coming to question number 37. F circle G is given, g of x is given, find f of x minus 3. So first of all, I'll be finding it out. G inverse of x. What is G inverse of x? X plus 1 upon 2 is going to be G inverse of x. Now f of x. How do I find f of x? F circle, G circle, G inverse of x is going to be nothing but what? F of x. Because G and G inverse will get cancelled. So how do I find it out f of x? F of x can be found out by F circle, G circle, G inverse of x. So that will become nothing but what? F of x. So in F circle G, if I plug in it out, G inverse of x, I am going to get it out f of x. So what is that? In F circle G, I should plug in G inverse so that I will be getting it out f of x. So substitute G inverse in this one. So it becomes x plus 1 upon 2 plus 1 divided by 2. So it becomes x plus 3 upon 4. That is f of x. Now I am asking f of x minus 3. So it becomes x minus 3 plus 3 upon 4, which is x upon 4. These are very high level questions. So pause the video or slow down the speed and then check it out once again, or play again and again and see. Question number 38. Find f inverse of x. X square minus 1 upon x square plus 1 equals to y. X square minus 1 equals to x square y plus y. So x square minus x square y equals to 1 plus y. X square common, 1 minus y equals to 1 plus y. So x square equals to 1 plus y upon 1 minus y. So x equals to plus or minus square root of 1 plus y upon 1 minus y. But it is negative. So therefore I am going to take only negative answer. Minus square root of 1 plus x divided by 1 minus x. This one was y. Then replace y with x. Question number 38. F inverse of 1. When do I get it out 1? 39. When do I get 1 in the table? 0. When do I get 0? I'll be getting it at, use the graphing calculator because it is not the exact value. So for part 2, use the graphing calculator, negative 0.682. F inverse of 2 for part 3, also use the graphing calculator, positive 0.682. For part B, we know that f of x equals to f inverse of x equals to x. So we are going to solve it out. F of x equals to x means f of x is x cube plus x plus 1 equals to x. X gets cancels. X cube equals to negative 1. So what is going to be the value of x? X equals to negative 1. Question number 40, f of 0. So f of 0 is 1. So f of 1 is going to be nothing but how much? Negative 5. Now do the completing the square. Take x2 common. X square minus 4x plus 1. So 2 times of x square minus 4x plus 4 minus 4 plus 1. So 2 times of x minus 2 whole square minus 8 plus 1. So it becomes 2 times of x minus 2 whole square minus 7. What is the range? So it range is always greater than or equals to negative 7. Then find f inverse and state domain and range. So part D, 2 times of x minus 2 whole square minus 7 equals to y. 2 bracket x minus 2 whole square equals to y plus 7. X minus 2 whole square equals to y plus 7 upon 2. So x minus 2 equals to plus or minus square root of y plus 7 upon 2. So x equals to 2 plus square root of y plus 7 upon 2 plus or minus. But we know that it is always less than 2. So my f inverse of x will become 2 minus square root of y x plus 7 upon 2. What is the domain and range? So we know that domain range x is less than or equal to 2, y is greater than or equal to negative 7. They get swapped. So x is greater than or equal to negative 7, y is less than or equals to 2. Now question number 41. Show that f is a self-inverse. So what am I going to do that? 3x minus 1 upon x minus 3 equals to y. 3x minus 1 equals to xy minus 3y. 3x minus xy equals to 1 minus 3y. X common, 3 minus y equals to 1 minus 3y. So x equals to 1 minus 3y by 3 minus y. So same, f inverse of x will be equals to 3x minus 1 upon x minus 3. It is a self-inverse. Hence, f of k, f circle of fk, find the value of that. So I quickly add a page over there. F circle of f of k. So we know that f and f inverse are same. So they get cancelled and we get the answer as k. Part C, find the value of f of g of minus 2. F of g of negative 2. What is g of negative 2? Is 5. F of 5. Plug in 5. 3 times of 5 minus 1 by 5 minus 3. So plug in negative 5. 3 times of negative 5, negative 5. So it becomes negative 16 upon negative 8, which is going to be 2. Then finally, on the same diagram, sketch the graph of g inverse of x. So what are the points? The points are negative 2 comma negative 5. It becomes negative 5 comma negative 2. And it is negative 1 comma 0. It becomes 0 comma negative 1. And 2 comma 6. It becomes 6 comma 2. So it becomes negative 5 and negative 2 somewhere over here. 0 comma negative 1. X is 0, y is negative 1. Then 6 comma 2. 6 comma 2. So this will be the graph of f inverse of x. Coming to question number 42, the function f of x is given as x plus 2 whole square minus 3 and g of x is ax plus b. And it has been given that f of g of x means f of g of x. What is g of x? G of x is ax plus b equals to nothing but what? 4x square plus 6x minus 3 upon 4. So plug in that one, it becomes ax plus b plus 2 whole square minus 3. equals to 4x square plus 6x minus 3 upon 4. Comparing the coefficients of x square. What are the ways I'm going to get x square? This is 4 over here and only ax becomes x square. So it becomes a square. So from there a equals to plus or minus 2. But he told that a is positive. So therefore I'm going to write it as a is plus 2, not minus 2. Now once I get the value of a, what am I going to do that? I'm going to plug in that one. It becomes 2x plus b plus 2 whole square. 2x plus b plus 2 whole square should be equals to 4x square plus 6x minus 3 upon 4. Now this is in the form of a plus b whole square. A plus b whole square. Now 2ab term will be having the x. So what's the 2ab term? 2 times 2x times b plus 2. That only will be having x, and the x term from over here is 6x. So x and x gets cancels. So what I'll be getting it out? 4 times of b plus 2 equals to 6. So b plus 2 equals to 6 upon 4, which is 3 upon 2. So b equals to 3 upon 2 minus 2. So b equals to negative 1 upon 2. That's going to be the answer for a and b. Next, the function h and k are defined by h of x equals to 5x plus 2 and k of x respectively. Find the value of c such that h of k of x has equal roots. So he is telling that h of k of x has equal roots. So I add a page over here. H of k of x has equal roots. What is that? K of x will become 5 of cx square minus x plus 2 plus 2. So what does that becomes? 5 equals to 0. 5c x square minus 5x plus 10 plus 2 equals to 0. So it becomes 5c x square minus 5x plus 12 equals 0. Now equal roots means b square minus 4ac equals to 0. So 25 minus 240c equals to 0. That gives me c as 5 upon 48. That is the value of c. Coming to question number 43. F of x is given. Then solve the equation g circle f of x equals to 1. G circle f of x. F of x is square root of x plus 1 equals to 1. Now squaring this side. So square root of x plus 1 whole square equals to 1. Now, so square root of x plus 1 equals to 1. So what does it happens? 1 and 1 gets cancels. So square root of x plus 1 equals to 0. Means x plus 1 equals to 0. It implies x equals to negative 1. Find f inverse in the simplest form. So for f inverse, square root of x plus 1 equals to y. Square root of x plus 1 equals to y minus 1. X plus 1 equals to y minus 1 whole square. X equals to y minus 1 whole square minus 1. So f inverse of x will be equals to x minus 1 whole square minus 1. You can simplify this or you can leave it out over here. Next, find the function h of x such that h circle of f equals to g. So h circle of f equals to g. So let me add a page over here and write down what is f of x and what is g of x. F of x is given as square root of x plus 1 and g of x is given as x square. And what is he asking us to prove? He is asking us to prove or find h circle f equals to g. H circle f of x equals to g. So what is the value of f? What is the value of h of x? So h of f of x. What is f of x? Square root of x plus 1 equals to g of x. What is g of x? G of x is x square. So what is happening now? Let this equals to y. Square root of x plus 1 equals to y. So this becomes h of y. So it becomes square root of x plus 1 equals to, already we are finding inverse, we have already found, but then also I'm doing y minus 1 whole square. So x equals to y minus 1 whole square minus 1. So which becomes y square minus 2y plus 1 minus 1. So it becomes y square minus 2y. So x is nothing but what? Y square minus 2y whole square. So we can see that h of y is this one. So what does that implies? H of x equals to x square minus 2x whole square. Next is asking k of x, f of k equals to g. F circle k equals to g. What is k of x? So f of k of x equals to g of x. F of k of x equals to g of x. G of x is x square. Now what am I doing it out? Applying f inverse on both sides. So that f and f inverse gets cancels. I'll be getting k of x. K of x equal to f inverse of x square. If you remember f inverse of x square, what was f inverse of x? F inverse of x was x square minus 2x. So f inverse of x square will become x square whole square minus 2x square. So which will become x power 4 minus 2x square. And coming to the last question, the diagram shows the part of the graph is defined by f of x equals to this much. Find an expression for f inverse of x. So 1 plus root x equals to y, square root of x equals to y minus 1, x equals to y minus 1 whole square. So f inverse of x equals to x minus 1 whole square. State the domain and range of f inverse of x. So domain and range, we can see that domain and range for function f is x greater than or equal to 0 and y greater than or equal to 1. So for f inverse, it will become swapped, x greater than or equal to 1 and y greater than or equal to 0. On the same diagram, sketch f inverse of x. So it may be looking it out in this way approximately. Coming to part D question, so he's telling that f of x equals to f inverse of x. Find the value of x. So basically, when f of x equals to y, then what does that mean? F inverse of y equals to x. But he told that this is also nothing but what? F of x. They are equal. But f of x equals to y. What does that mean then? X equals to y. So what can I write? F of x equals to f inverse of x equals to x. So both are equal. So what is f inverse of x? We got it out, x minus 1 whole square equals to x. So x square minus 2x plus 1 equals to 0. So I get x square minus equals to x equals to x. So x square minus 3x plus 1 equals to 0. So find the quadratic now. Minus b plus minus square root of b square minus 4ac upon 2a. So it becomes 3 plus square root of 5 upon 2. I take only positive because according to the values, x is, we have to take only positive value. 3 plus square root of 5 divided by 2. Only one answer and not 3 minus 5, square root 5. So therefore the answer is 3 plus square root of 5 upon 2. That completes the video. See you in the next video. Bye.